Okay, good morning, all of you, right? I hope you can audible me well, right? Please give some response me. Can you hear me well?
Good morning, sir.
Good morning, right? Thank you. Right. This is the first day we are going to meet, right? So first of all, I will introduce myself, right? So I'm Ruan, right? So one of your lecturer attached to the IAT department. So starting from today, I will conduct several subjects courses, but to you in this semester, I will conduct the calculus course. So let's see. This is a totally maths course. So sometimes you may question me why we are doing these kind of mathematics courses because you are in the technology stream. So you have to keep this in your mind. Without maths or physics, actually, even you are in any kind of engineer or software developer or anything, but without the mathematics knowledge as well as the physics concept, we cannot uh, come to the level what we are expecting. That's the reason. So we have to learn this area with this. At least we have to touch this area. Then we can go something more as you expected. So that's the reason we are going to learn this mathematics subject uh, in your technology stream. So anyhow, I will share you the curriculum first. So this is the course content and the things what we have. So this is a 2 credit course. So we have 30 lecture hours to complete, right? So we have to, as well as we have to complete some kind of tutorial. Then you can find out the objectives and learning outcomes throughout the course and course content. So I will share these details later. So after you complete this course, right? So you have to go. Right? You should be able to go through this area well when you have completed the full lecture course. So right. So final evaluation, it's just like this. So finally you have a semester examination on this. Sorry, today actually I'm not well, right? So please sorry about that. So you have a end semester examination. So 70% actually comes from the end semester exam, and now you have mid semester exam. So 20% will assess you see the mid semester examination, and you should have continuous assessment type. That means assignment or quizzes. So 10% will come from the those areas. So you should involve all of these three evaluations. Otherwise, you cannot achieve a good grade for this subject. So these are the things about the course, because I need to show this before to start the lesson. So now you know how to work with this course, how to achieve a good result, right? Okay. එතකොට මේ විදිහට තමයි ෆයිනල් ඉවලුවේෂන්ස් මේ කෝස් එකේ වෙන්නේ. ඇත්තටම ක්විසස් සහ අසයින්මන්ට්ස් වලින් 10% විතර 10,000ක ප්‍රමාණයක් එකතු වෙනවා. ඒ වගේම mid semester exam එකකින් 20ක් පමණ එකතු වෙනවා. ඒ වගේම end semester examination එකකින් තමයි ගොඩක්ම percentage එකක් එකතු වෙන්නේ. 70ක් විතර target කරන්න පුළුවන් end semester exam එකකින්. ගොඩක් අමාරු subject එකක් නෙවෙයි මේක. But when you learn this one, you can apply in the different areas what we are going to study later. That's the thing. Right. Okay, let's start about this course. So course title, sometimes you know that the curriculum also they mention it is changing time to time. So IA 1201 earlier, there are several versions because now it is revising. So don't get the incorrect format. So I will check it what is the recent latest one. So I hope this one, right? Anyhow, in the calculus, so the term calculus අපි නිකන් සිංහලෙන් කියනවා නම් අපිට කියනවා නිකන් කලණය කියලා, right? So we call calculus as කලණය, right, in Sinhala. So inside this term there are lots of areas in the mathematics we have to touch. So as the very first day, right, as the very first day, so I will give you the introduction about the first step of this calculus lecture series. So today we are going to talk about the function, right? අපි functions ගැන තමයි අපි මේ first day එකේ කතා කරන්න යන්නේ, right? So I will share this reading material after the lecture, right? So you can go through it also. Because calculus is totally depend upon the function. So we have to, with the good knowledge about the functions and how they are behave, right? Without the well-known about the functions, actually we cannot jump on this course. That's the case, right? So first we have to declare. So we have to introduce the functions, the term functions, right? So let's see this slide or this page. The function related to an input to an output, right? Function එකක් සම්බන්ධ වෙන්නේ input සහ output අතර සම්බන්ධයක්. ඒ සම්බන්ධයට තමයි අපි function එකක් කියන්නේ. The relationship that we called the function from input to output. So there are always three main parts of the function. We should have input, then we should have a relationship, and then we have a output. So if we have a function, we can put our inputs into the function and we can take out the outputs just like a function. So it is just like a generator, right? We can give the inputs, then it will release the outputs for us, right? Okay. So let's see some very simple example. So functions are, we can find the functions in the different manners. So we have to work with those. So this example also kind of a function. Let's see. We have an input and the relationship is we are going to multiply by 2. That is the relationship, right? We are in a different discrete inputs and we have a relationship. Relationship is multiply by 2. That is actually function, right? Whatever we are going to input, it will multiply by 2. and given the output. So let's see these terms, numbers. So using this relationship, we can find out the output. So is this a function? Now we have to clarify. Is this a function?
Recording in progress.
The thing is, now we should have to learn how to find out the function, right? Because every relationship or every input or every output not give us a function. So we have to find out or learn the way how to find the function. So this one, no matter, this is give us a function, right? I will go to next one. So I will take another examples here. X square. So we can take this one, y equal x square, right? So this again a function. So we can give or put the inputs for x and take the output. For example, 0, 1, 2, like that. So when we insert 0 to this function, right, we have output 0. Right? When you insert 1 to this function, we have output 1. When we input number 2 to this function, we have output 4. So this is a function, right? We call this a scaling function. As well as this one. Again, this is a function. This is also a function. So not like that this polynomial, right? There are so many examples which act as a function. Sine, cosine, tangent also are their functions, right? So during this course, we may meet, it may meet, there are several different functions. So we have to deal with this, be carefully, because each and every relationships are not the function. So we have to find or clarify whether they are functions. That's the main target. I will teach you how to do that, right? So we have to learn a common representation of the function, because in O level or A level, we are very familiar with this way, right? Y equal x squared plus 2, like that. So y equal x minus 1. This is a function. We familiar in this way, but now we have to change this representation view, right? Because there are some formal format, right, to represent the function, right? It is not a rule, but if we familiar to write the function in this way, so it is very easy to handle. That's the case. So let's see what is this f, right? F is a function, right? And inside we can input some values to this function and we have a output. So according to this one, function is x2. So these are the outputs. We can set input here. This is the function, right? So this is the way of representing the formal way of the function. මේක තමයි function එකක් represent කරන අපි කතා කරන formal way එක, right? එතකොට මේ fx කියන notation එකෙන් තමයි අපි මොකක් හරි function එකක් represent කරන්න. එතකොට මේකේ function එක අපේ x squared නේ. x squared කියන function එක අපි මෙන්න මේ විදිහට notation එකකින් represent කරනවා. ඒක තමයි formal way එක. right? ඒකට අපි පුරුදු වෙන්න ඕනේ. f විතරක් නෙමෙයි අපිට එක functions තියෙනවා. මේකට different function එකක් ගන්න ඕන නම් අපි ළඟ තියෙනවා x ඔය වගේ එකක්. එතකොට අපිට මේක fx කියන්න බෑ. මොකද fx කියන්නේ x squared නේ. එහෙනම් අපිට ඊළඟට කියන්න පුළුවන් gx වගේ එකක්. එතකොට මේක තවත් function එකක්. right? hx කියන්න පුළුවන් තව එකකට. ඒක තවත් different function එකක්. ඔය වගේ we can represent different function using this notation, right? Common representation. So you have to familiar with it, right? Right. Next thing you need to familiar, right? Function can have any type of input, right? So don't get in a different meaning of this term, right? You see here you can see we have I have represent a function here x equal 1 minus x plus x squared. So this is the formal way of representing the function. This okay, right? Is the same function as, so here I use a different symbol to represent. Instead of x, I have represent q, simple q here. And again, another letter. So these are the variables, but they are just, so we know where to put the value. So the thing is, we have to identify the correct variable here, right? So variable means when we take this function, right, there are two kind of variables, right? Our input, right, we call there as what? Independent variable. And the output, right, output we can call they are dependent variable, right? So whatever we have insert here, they are independent, and the what we can have after the inputting that inputs, that means the outputs we can call as a dependent variable. So those are the variables. So no matter, we can represent a function. So function can have any type of input, right? That's the thing. So here theta means most probably we are representing the angle. Here, this one, sometimes these are area. So these are numbers, right? Like that. So the thing is, independent variable is different, but the function is very similar. That's the things I have to mention. I need to mention through this window, right? අපිට function එක similar වුණාට අපි apply කරන තැන අනුව use කරන තැන අනුව අපිට ඒ function එකේ පොඩි වෙනසක් දකින්න පුළුවන්. ඒ තමයි අපි කතා කරන්නේ අපේ independent variable එක සාමාන්‍ය real number එකක් වගේ නම්, right? අපිට ප්‍රශ්නයක් නැහැ. ඒක මේ වගේ notation කරන්න පුළුවන්. හැබැයි අපි area එකක් අපේ independent variable එක area එකක් නම්, නැත්නම් අපේ independent variable එක angle එකක් නම්, so we are representing the same function as like this, right? Let's move to the next one. right? This is the very well-known pattern of the function, right? So this is the things what we have learned at the O level and the A level. So this is the very familiar representation of the function, right? So but still you can see x is the input and y should be the output. So relationship is x square, right? Right. So then this one express that about the what types of things do functions process, right? So function may be actually the inputs may be numbers, letters, different things. So the thing is we have to clearly identify that. So the thing, the term here we have to learn what is called sets. So කුලකයක්, right? කුලකයක් කියලා අපිට introduce කරගන්න අවස්ථාවක් හම්බ වෙනවා. ඒක තමයි අපි බලමු මෙහෙම දෙයක්. So when we introduce the even number, so when we introduce about the even number, so we cannot write number 1, number 3 here. So we have to represent the even numbers as like this. So this now the even number is a kind of a set, right? But the real number, so each and every numbers are there in real, but when we talk about the even numbers among the real numbers, so it is a set. එතකොට අපි සම්පූර්ණයෙන්ම තාත්වික සංඛ්‍යා කියලා ගත්තොත් ඒක ලොකු කුලකයක්. ඒ කුලකයකින් අපි සබ් කුලකයක් තමයි එතකොට even number එකක් කියන්නේ. එතකොට මේ අපි කතා කරන්නේ input variable even numbers ද නැත්නම් තව දෙයක්ද real numbers එකද නැත්නම් ඒ කියන්නේ කුලකයේ මොකක්ද කියලා අපි හරියටම identify කරගන්න ඕනේ. So function takes elements of the set and give back element of the set. අපිට inputs විදිහට අපි තෝරගන්නේ මොන elements ද මොන කුලකයේද කියලා අපි දැනගෙන ඉන්න ඕනේ. එතකොට ඒකට අදාළව තමයි අපිට output එක හම්බ වෙන්නේ. ඒකත් එක්තරා විදිහක කුලකයක් වෙනවා. So that's the things explained in this slide. So these are not too much things. So that is why I'm passing these through, right? So this is the things what I need to explain, right? Because we have to know, we have to way of identify whether this function or not, right? So these are the rules, right? So these are the rules. Function, right, must work for every possible input value, right? Function must work for every possible input value. අපි ළඟ input values තියෙනවා නම් ඒ හැම input value එකටම function එක වැඩ කරන්න ඕනේ. right? 1000ක් තිබිලා 999කට වැඩ කළා එකක් හරි වැඩ කරන්නේ නැති එකක් තියෙනවා නම් වැඩක් නැහැ. If there are 1000 inputs but it will work only 999 and it will not work for only one, we cannot explain it is a function. It's not a function, right? That's the first thing you have to learn. And it has only one relationship for each input value. It has only one relationship for each input value, right? ඒ කියන්නේ එක input value එකකට තියෙන්න පුළුවන් එක relationship එකක් විතරයි. අපි තව විදිහකට කියනවා නම් පොඩි උදාහරණයක් ගමුකෝ මේ let's see this figure, right? So in this side, this set it represents the inputs and this set it represents the output. So there are inside this set, right? So there are some element. So you can see in each input, we can find the output element, right? Okay, to this, when you consider this one, this element, it has a output. When you consider this element, it has output, no problem. When you consider this element, yes, it has output. When we consider this element, it has output. When we consider this element, again, it has output, but the same value. Okay, now again, we have to clarify this, right? A function relates each element of a set with exactly one element of another set. Okay. Yes, first I will give the answer. This is a function, no matter. Make a function එකක් තමයි. අපේ element එකකට, right? Element input පැත්තේ තියෙන element දෙකකට එක output එකක් ආවා කියලා එක function එකක් නොවෙන්නේ නැහැ. ඒක function එකක් තමයි. මේක rule එක satisfy කරනවා. Right? මොකද්ද rule එක? It must work for every possible input values and it has only one relationship for each input value. Right? මේ element එකකට එයාට තියෙන එක output element එකයි. ඒක තමයි අවශ්‍යතාවය. Right? That is the need. So let's move to the next one. Here you can see the situation what we have to learn, right? So here each and every element in the input set, right, it has the one-to-one connection. එකිනෙකට, right? අපි එහෙම කියනවා සිංහලෙන්. One-to-one relationship. So this is a function. But if a single element has one-to-many relationship, right? For example, if this element has again another, it will make another output at a different time. So this is not a function. That's the thing we have to identify. That means like this way. We have a function called fx, right? අපිට fx කියලා function එකක් තියෙනවා. මම මේකට values දෙකක් දානවා. එක දානවා, බිඳුව දානවා. output විදිහට මට එනවා අවස්ථා දෙකටම number 5. We don't know what is the function, but we see the output and these are the inputs. Make a function එකක්. ප්‍රශ්නයක් නැහැ. මේ එක input element එකකට for single one element it has a output and next element also has a output, no matter. මම තව function එකක් ගන්න. I will take another function called gx. I will insert the same inputs 1 and 0. So at the very first time when I insert the number 1 for this function, it will shows number 5 and again I will insert number 1 and it will give me a number 6, right? So now we have a problem because we don't have exact one relationship, because at what first time it will give us one number 5 and in the second case we have number 6. It will give us a number 6. So we cannot define the function well. So this is not a function, right? Because it don't have one-to-one connection. So that's the thing. So we have to identify what is the function and what is not. So this is the only single rule that it explains if you remember these terms, you can identify whether this is a function or not, right? Okay, in this case, we use this term, right? One to many, if the relationship is one to many, right? It doesn't shows as a function, right? If it is a one to many, but if it is a many to one, no problem. One to one, nothing, right? It should be a function. Again, if it is a many to one, no matter, we can call it it's a function, but that relationship is one to many, right? We cannot call it as a function. That's the things you have to remember. So, for example, for many to one function, actually, we know that when you take this kind of example, fx equal x squared, right? So, if you insert thing -1, what happened? Output should be 1. If we insert +1, again, output should be 1. So, inputs are different, but output is similar. So that means this relationship have many to one connection, but it did not break the rule, so it is a function. So we know these things. Let's move forward. Here in this example, you can see we have one to many relationship. So this is not a function. So by looking at the things, you can identify whether this is a function or not, right? So I will share the whiteboard now. Please give me 1 second. Okay, I forgot to tell you at the beginning. Please put your index number to the chat box and send it to me. So automatically the chat box will saved after the session, so I can take the attendance by look at the index number. So please put your index number into the chat box and send to me, right? Okay. So if you need, you can take these short notes for your end. So anyhow, I'm using the whiteboard and the lecture slide also during the course, right? So let's define the function first in the well manner, right? So if we can write like this, some expression, right, where each input we can call x, right, as inputs, has exactly one unique, this is the term, right, one unique output y, right? This the things, only things that you have to remember, right, to identify the function, right? Some expression where each input x has exactly one unique output, that should be a function. That is the only thing you have to remember, right? One unique output. So many to one, you cannot say as a function. That's the things what I explained. So in the reality, you can see lots of way of functions. It may be table, or it may some formula, right? So let's consider a table here. For very simple one, if we take fish and the weight of the fish as the output, so we have number different fish. First fish has a weight of things 200 grams. Second one maybe 300 grams. Third one 250 grams. Fourth one 400 grams. Right. So like that, this is again a function, right? Because we can find a unique output for our input, right? So we can see function as like this way also. But if you see this in fourth fish again, see 200 grams, no problem. Again, should be a function according to our definition. Again, let's take another fish, number 5. Not number 5. I will take the earlier one, number 1. Now the weight 220. Now the function, it is not now break the our rules. It is breakout rules. Why? This number 1 have 200 here, and number 1 again give us a 220. So this is not a function. So that is why, that's the way we are clarifying whether it is a function or not. So very simple manner to express the function or identify the function. So sometimes we can see the function as a graph, right? So this is a cycle x squared, right? So here you can find. So for two x values, you may have one y values here, but not a problem, right? Not a problem. If this is a y equal x squared, this should be like that way, right? That is why I put -1 here, right? So anyhow, this satisfy our rules. So it is a function. So you can see the function as graph, as tables, as formulas. So you may meet functions in a different way, but you have to identify whether it is a function or not first. So if you see the functions as graph, right? If you see the functions as graph, right? For example, let's take this graph. So this is the first one. Again, I will draw this one. This one.
Recording stopped.
Okay, sorry, I have dropped suddenly due to the network failure. Right now, I think it is okay.
Recording in progress.
At last, I have drawn some graph, right? This one. Just like the third one, but little bit different. Right? So these are the hello. These are the hello. Can you hear me?
Yes, sir.
Right. Okay. So these are the graph what I have drawn at the last. So whether you have to find out whether they are functions or not. So there is a very simple test that you can apply on the graph. That is called vertical test. vertical line test. You can draw number of vertical lines. Sorry, in millions of or thousands of millions of number of vertical lines in that way, and find whether one vertical line have two y values or output values. That is the things that you have to find. That is called vertical line test. So if you draw number of lines here, vertical lines, so in this graph you cannot find two y values or two crossing in a single vertical line. In here, this is only one, this line one, this line one, this line one, one. No two positions. So this is a function. When you consider this graph, yes, there are only single crossing, right? So this is also a function. So tell me, how about this? If you draw vertical lines, is this a function? Function එකක්ද කියලා අපි graph එකකදී හොයාගන්න ලේසිම ක්‍රමය මොකද්ද? අපිට තියෙන test එකක් vertical line test කියලා. By looking අපිට මේක කියන්න පුළුවන්. මේ වගේ vertical lines ඇන්දර පස්සේ අපේ function එකේ output එක එක තැනකද නම් ඡේදනය වෙන්නේ, cross වෙන්නේ, right? එහෙනම් ඒක function එකක්. ඒ කියන්නේ හැම single input එකකටම එක unique output එකයි තියෙන්නේ. ඒක තමයි අපි මෙතන test කරන්නේ මේ vertical line test එකේ. එතකොට මාගේ ප්‍රශ්නේ තමයි මේ තුන්වෙනි graph එක මෙයා function එකක්ද නැද්ද කියන එක. කාටද උත්තර දෙන්න පුළුවන්? Is this a function or not?
Function.
Yes, it's a function. No worries about that. Okay. Then I will come to this one. Tell me. Someone can tell me, is this a function?
Function.
Yes. So sometimes you may have some problems at x equal 0, right? What happened if the vertical line test is passed? Up to that one, up to that negative infinity to 0, no matter, it will pass the test, and again 0 to positive infinity, no matter, it will pass the test. At x equals 0, what's happened? මේක x සමානයි බිඳුවේදී මොකද වෙන්නේ? මේ වගේ මේ ෆන්ක්ෂන් එකේදී අපිට ඩිෆයින් කරගන්න නැතිනම් ඒ කියන්නේ මෙයා අනන්ත 0 වලට එනකොට ඇත්තටම අපිට පේනවා මෙයා they are going to infinity, right? So no matter, but it will pass the vertical line test, right? Because at x equals 0 there are no two y values, right? Because they are going to infinity, no, right? No problem, because this is going to positive infinity, this is going to negative infinity. So I will explain this matter later, but anyhow, at this moment, please remember this graph shows about the function. So now I will come to the last one. And apply the vertical line test. So this one, last one.
Not a function.
Yes. Why?
Vertical line cross the 2 point.
Yes. For this area, you can find it a better way. See, we have 2 points. Here we have 2 points. So that means at any single value, it has 2 output values, 2 y values. So it will not satisfy our definitions of the function, because we write down it should have a unique output. So it will not satisfy it here. So this is not a function. It will fail the vertical line test, right? So that is the way, simple way of understanding whether the graph, if the function is appear as a graph, so you can simply apply the vertical line test and see whether it is a function or not. Right. I will move forward. Let's take a formula. X squared plus y squared is equal to 25. So I need to clarify, is this a function or not? How to do? Now we have a formula or equation. Let's in a manner of what we have seen as a function, let's bring the x squared to the right hand end. So now y squared is equal to 25 minus x squared. Then I will take the square root of y. I need to take the y, right? So now what's happened? We have a y here, but when we take the square root of any element, we should need to apply positive or negative values of that square root. This is the formal mathematical rules when we are taking the square root, right? So if you, okay, now tell me, so my question is this one. This is the formula, what I have, x squared plus y squared equal to 25. Now I have simplified into some familiar format. Now we have this. So my question is whether this one is behave as a function or not. Can we introduce, so can we express this one is a function?
Not a function.
Why?
Plus and minus values are two different answers.
Yes, in our answers, in our each and every answers, we have 2 y values, 4 single x values. You can insert some values here and see we have 2 y values. First one is plus. I will notate, give a notation to the value d as the simplified value inside this square root. So other one is minus d. So this have 2 values. So we cannot conclude that, or we cannot represent, or we cannot express this formula is act as a function, right? We cannot say, but someone can write at the initially we can someone can write this way: y equal 25 minus x squared. Now I will ask this one, is this a function?
Yes.
Yes, your answer is correct, because now I represent only single part. Now I take only this side, right? So individually this function behave this formula behave as a function. And again, when we consider the other portion, y equal minus square root 25 minus x squared. If someone express this and asks from you whether this is a function, answer is yes, because in each single x value, it represents only single y value. So individually they are behave as a function, but when we consider a group or both in this level, it does not represent the function, right? So we have to take care about how the formula represent to us. So be careful, right? Okay, let's move. So actually, this the x squared plus y squared is the formula of circle, right? I hope you have learned this before. So actually, in here, if we write x squared plus y squared 25, I can write 5 squared. So this one represents the radius, right? Is equal to 5. So this is the formula of the circle, right? So if you graph this formula, so it just like, okay, the thing is now you can simply say, so this, if it is a circle, if we apply the vertical line test, you can see that is not will satisfy the vertical line test. So it is not the function, right? Okay, but if we take the individual part, right, that means this will represent the upper side of the circle, right? If we take those individually, it will pass the test, right? So it will behave as a function. And the other one also. This will describe the bottom part of the circle. So if we apply the vertical test, you can see it will satisfy our conditions. So it will behave as a function. That's the things happening inside. So individually, we can express these are the functions, but when we took both together, it will not behave as a function. එතකොට මේ වෘත්තයක සමීකරණය තමයි මේ අතරම ලියලා තියෙන්නේ, right? එතකොට මේකෙදි අපි පොඩ්ඩක් සිම්ප්ලිෆයි කරලා බැලුවොත් අපිට පේනවා එක x value එකට y value දෙකක් එනවා. ඉතින් ඇත්තට මේක අපිට අපේ රූල් එක සැටිස්ෆයි කරන්නේ නැහැ. ඒතකොට ඇත්තටම graph එක ගහලා බැලුවොත් ඒකිනුත් අපිට ටෙස්ට් එකක් vertical line test එක දාලා බලන්න පුළුවන් මෙයා function එකක්ද නැද්ද කියලා. එතකොට ඒකිනුත් fail වෙනවා. එතකොට මේක function එකක් නෙවෙයි. නමුත් individually අපි ගත්තොත් මේ sides දෙක වෘත්තේ upper portion එකක් උඩ පැත්තත් යට end එකත් ගත්තොත් individually they will act as a function, right? Vertical line test එක apply කළත් අපිට ඒක දැක ගන්න පුළුවන්, right? Let's take another example. So we can meet these kind of functions when you are working on the calculus. We call that is piecewise function, right? Piecewise function. What is piecewise function? First we have to know it before learning the behaviors. So we can interpret piecewise function as like this. The functions t change depending on the input value, right? The functions change depending on the input value, then we can call those as a piecewise function. Let's take an example, very simple example. You know the absolute value function. අපි කියන්නේ මාපාංක ගන්නවා කියලා. Absolute value එක ගන්නවා කියලා. Let's say we have a function y equal x, not x, absolute value of x. Right. So this is a piecewise function. Why? Let's see. Definition, let's say the definition, the functions change depending on the input value. So the thing is, if x is greater than or equal 0, we can define the function as directly x. But if x is lower than 0, we have to define the function as minus x. So this is the function of this absolute, taking the absolute value of any number, right? So you can see another function well, and function defined in two different input values. So there are some two categories. So according to the definition, the functions change. Actually, these are two totally different functions, because this is x, this is minus x. There are two functions, and function change depending on the input value. The input value මත මේ function එක depend වෙලා. මේ input value මත function එක depend වෙලා කියලා පේනවා හොඳට. Right? So we can see different two functions which is depend upon the input value. So absolute, taking the absolute of the number means, actually variable means it is a piecewise function. So now you have some idea about the piecewise function. There are some different kind of functions. So piecewise function is another type of the function that we can meet throughout this course. So how we define the piecewise function, the functions change depending on the input value. So we can clearly see it by using this simple example. So again, you can graph the piecewise function, right? You can graph. How to graph the piecewise function? There's a way. We can graph each piece individually for the given domain, right? Again, you have a new word. I will write it here, domain. We will discuss little bit later, but domain, අපි සිංහලෙන් කියනවා වසම කියලා, right? Okay. Domain means actually the input, what the inputs what we have, right? අපිට තියෙන inputs ටිකට තමයි මේ domain එක කියන්නේ, right? අපි කතා කරමු මේක ටිකක් පහුවට. So we can individually graph the piecewise function, right? For example, this function, absolute function. So we have to divide the two pieces. When the x equal or greater than 0, we have to draw that part first. Y equal x. When the x is lower than or less than 0, it should be, sorry, y equal minus x. So this one is x, suddenly disappear the drawing panel. Right now it is okay. This one is x and this one is minus x. Right. So according to this way, you can represent the or graph the piecewise function. How to graph this? You can use the categories one by one and draw the graph according to that function. That is the way. Right? Let's take another example. We have a function called gx. Right? So it will represent, this is the way of represent the function now. Let's take some kind of not a simple, little bit hard one. Function give the output 0 for x. Let's take less than or 0 minus 1. And intermediate level gx is represent 1 square root of 1 minus x squared within this range, x minus 1 to plus 1. And x greater than or equal to 1, the function behave as x. So these are the piecewise functions. So we have three categories of inputs. So why we call this a piecewise function? Because function is change depending on the inputs. So we have three functions. Here y equals 0 or gx equals 0. Here gx is square root of 1 minus x squared. Here gx is x. I make a piecewise function එකක් කියන්නේ මෙයාගේ function එක වෙනස් වෙනවා. මොකක් මතද? අපේ inputs මත. ඉතින් inputs මත මෙහෙම function එක වෙනස් වෙනවා නම් අපිට යාට කතා කරන්න පුළුවන් නමක් දෙන්න පුළුවන් piecewise functions කියලා. Right. So let's try to draw the graph for this piecewise function. So there are some points that we have to represent. -1, +1, right? Okay. So x is less than -1. What is the output of the function? Always 0. So we can represent it first. Up to x is less than 1, -1. So we can draw the graph like that. Okay. Now we have a critical point. So now we have to draw the graph in between -1 to +1. So first we have to identify this function. Now you already know it because I can write here the function as like this, say y equal 1 minus x squared, because I wrote this one earlier. So this is the function of like the circle, but not the circle, the portion of the circle, the sides of the circle. Can someone tell me, is this the upper portion or bottom portion of the circle by looking at this function? මේක මේ වෘත්තයක අපි කියනවා ඉහළ කොටසද නැත්නම් පහළ කොටසද? කාට හරි කියන්න පුළුවන්ද මේක දිහා බලලා? Oh, yes, you are correct because I have expressed it earlier. So let's first let's take the square of both ends. Y squared is equal to 1 minus x squared. Then can write x squared plus y squared equal to 1. So definitely you can write this as a 1 times 1 square, no matter, because same thing happening. So this is the formula of a circle. So first you have to identify this as a circle, right? Then at this point, this has only positive values, square root values. So this should be a upper portion of the circle. So now I'm going to draw that part. From -1 to +1. So here you can identify the radius. So it is 1, that is why L, and center is the position 0. Then I can draw the upper portion of the circle. Right. This range is okay now. Again, next we have to find x greater than 1, equal or greater than 1 situation. So no matter this very simple case. So y equal x. That means when x is 1, y should be 1. So starting from this position, you can draw y equal x. This is this part, y equal 1 minus x squared. This part, y equal 0. So this way, right? So another thing I have to mention here. So this is x is equal or greater than 1. So in here, at the start point, you can represent some dark circle to indicate in that this represent the number 1 also, or positive 1 also, because x is equal or greater than situation. As well as here also you can do it at the end of this representation. You can draw a hard circle here. It represents the -1. It is included to this range, right? So that is the representing way of including or not included the first number, whether it is equal or not, right? Okay. Now I will come to the term. Actually, now I am already used this term, right? But I will give you the definition, right? So when we dealing with the function, right, we may met these two terms. They are we call domain, and the next one is range, right? Domain, range. Single කියන වසම, range කියන පරාසය, right? So we have to give the definitions for those, right? We can simply say domain. How? All input values, right? All input values, or all x values, right? All x values of the function, all input values of the functions, right? We can call it as a domain. So then what is the range? We can simply say all output values, right? All output values we can define it as a range. Right. Let's consider the functions and I write the domain and the range. So first I will take some critical points, right? I will write the function called finding the area, right? A means area. So area, how I find the area by so actually area of the square table, right? Having on the lab, right? So this is the area. So this is square table. So length is equal. So I will write the length as s. So how to find the area? We have to take this. That means a equal s square. So so this is the function. This is the function. The function gives us the area of the table. We only need to input the distance of the side. Right? Now I will ask the question. Okay, what is the question? Can you write the domain of this function? Can someone tell me? What is the domain of this function?
S.
S mean 1 to plus infinity. Right. I have one answer, 1 to plus infinity. Any other answer? Any other answers? Okay, why this answer contained 1? The area always need to greater than the 1 meter squared? No, ne? අපිට එහෙම constraint එකක් නැහැ නේද area එකට වඩා වැඩි වෙනවා කියලා. So we have to modify this range, right? This is not the correct one. So 1 to plus infinity, there's some problem at this number. So someone can tell me domain is belongs to let's forget about it. Domain is negative infinity to plus infinity. If someone give us an answer like that, so is it true? For example, negative, let's take the values from two values from this set. I will take -2. Let's take three values, 0 and +3. I will take these input values and put into this function. Okay. -2. Is it satisfy the function? Can someone tell? මේකේ -2 කියන එක මේ ෆන්ක්ෂන් එක satisfy කරනවද? hello හවුද නැද්ද?
No.
Yes. Why did you say no? What is the reason?
Length cannot be a negative value.
Yes. As a number, you can insert the -2 for this equation or function and you can take the output. But in the real situation, right, we are now, I explained it, this is the calculation of the area of the decks. So length should be what? Positive value, right? Positive length. So we don't have a negative length value. We cannot express the negative distance or length. So according to that application, right, we have to limit the domain. Why? We don't have a negative value of the distance or length. So our domain should be 0 to what? Plus infinity. You can write like this way, or you can write SC greater than or equal 1. Right? So this is the domain. Right? So for this example, because in mathematically we can apply a negative value, no problem, it will satisfy. But when we write the domain for this realistic application, right, you cannot take the negative values for distance. For at that case, you have to mention it. So our domain is like that. S is greater than 0. Right. Let's take this one. This again some kind of a critical situation. Y equal 1 over x. Right? Y equal 1 over x. Okay. What I need to find out a domain of this function without breaking any mathematical rules. Right? So what is the things that we have to consider for this function? Tell me. Here x is at this as a actually dominate, right? Sorry, denominator, right? X ඉන්නේ 1 over x, right? එක බෙදීම x. අපි කියනවා මේක සිංහලෙන් කියන්නේ හරය කියලා, right? එතකොට මෙතන අපිට තියෙන mathematical rules අපි follow කරන්න වෙනවා. අපිට මොකක් හරි සංඛ්‍යාවක් කොම හරි දෙයක් අපිට බිඳුවෙන් බෙදන්න පුළුවන්ද? මේක
No.
yes. මෙහෙම අවස්ථාවක් අපිට දා කරලා දෙන්න විදිහක් නැහැ. මේක mathematically maths කියන mathematical rules break වෙන point එකක්. right? එතකොට මේ වගේ denominator එකක් තියෙන වෙලාවට if we have this kind of denominator. So we have to care about that, and we have to interpret the domain without troubling that situation, this situation. So that means actually we have to define the x values as a domain, but without x equal 0 for this situation. මේ අවස්ථාවේදී අපි ඩොමේන් එක ඕනම සංඛ්‍යාවක් ඇප්ලයි කරන්න පුළුවන් නේ. නෙගටිව් ඉන්ෆිනිටි නම් ප්ලස් ඉන්ෆිනිටි එකක් එන්න පුළුවන්. So we can come from the negative infinity to plus infinity, but except 0, right? So we have to interpret the domain as like that. If we apply a 0 here, then we have this kind of situation that cannot be expressed in the mathematical problem, right? Undefined situation. Again, we have to care about this one also. So first thing is real and the realistic and the mathematical situation. And second one is, if we have these kind of denominators, we have to care about that, right? Third one, that we have the critical situation. Third one is, if we have a square root, it's a very simple one. If we have a square root, then we have to care about, take care. When we write the domain, we should apply 0 or positive numbers into this square root. We cannot take the square root of negative numbers, right? So in that case, we have to apply, or we have to write the domain equal or greater than x for this situation. So if we have square root, we have to consider it in well manner. If we have denominators, we have to consider it in another way. And the other thing is real problems. So at real problems, so we have to consider the real situation, like the negative length of the table. We cannot express it. So these are the things we may make, right? So let's take again some examples, then you can clearly identify. So let's take this one, fx equal x cube. So if someone asks what is the domain for this function, right? So no matter, you can apply any real number. So you can write the domain as like this, real numbers, right? This is the domain. So again, let's take another example. What have the denominators? 1 over x minus 1, x minus 3. Right. Now we have to see this one in critical way. So we have denominator. So what is the rule that we cannot make in mathematically? We cannot divide any number by 0. So in here you can see, when you apply 1, integer 1 to this formula, right? Here one portion of the lower end become to 0, then this will come to this undefined situation. So we cannot express that situation, or we cannot work on that situation. Therefore, we have to handle that situation in a different manner. So when we write the domains, we have to we have to remove that situation where the happening of 1/0 situation, right? Okay, so how we find the inputs that make the function become to 1/0 situation? So the thing is, take the denominators out and put into equal to 0. Then you can solve this. When x equal 1, this becomes 0, as well as when x equal to 3, this becomes to this. So individually you can apply x minus 1 into 0 and x minus 3 equal to 0. So you can find out the x here. So these are the values. So now you know the values where the function become to undefined situation. So we remove these two values from the domain, from the set of the inputs, and we write the domain without these values. So how to write it? Again, x belongs to real numbers, but you can write it in term except x equal 1, x equal 3. Please give me 1 second. Okay, thank you. Right. So this is the way. Sorry. Yes.
සර් මේ අපිට ඕක ලියන්න බැරිද මේ x කුඩයි එක n x විශාලයි 3 කියලා එහෙම ගන්න පුළුවන්ද සර්? එහෙම ලියන්න පුළුවන්ද?
කුඩයි මෙහෙමද?
ඔව් සර්.
x විශාලයි. එතකොට මේ මෙතන ආපහු ඔයාලට හම්බ වෙනව නේද රේන්ජ් එකක්? අතරමැද. එහෙනම් ඒකත්
ඒක අතහැරෙනව නේද සර්?
මොකද?
ඒ කොටස අතහැරෙනව නේද සර්? ඒ කියන්නේ 1යි 3යි
නෑ 1යි 3යි අතර මෙතන ඇත්තටම අතරින්නේ කෙලින්ම ඩිරෙක්ට් ඉන්ටිගර් එක 1 and 3 1යි 3යි විතරයි අතරින්න ඕනේ. ඒ අරින්න ඩොමේන් එකේ රියල් නම්බර්ස් කියන ඩොමේන් එකේ ඔය සෙට් එකේ අනිත් හැම එකක්ම තියෙනවා. නැත්තේ 1යි 3යි කියලා විතරයි. අනිත් තැන් ඔක්කොම මේක ප්‍රශ්නයක් නෑ, මේ ෆන්ක්ෂන් එක සැටිස්ෆයි කරනවා. එතකොට මෙයාගේ ඩොමේන් එක ලියන්න ඕනේ 1යි 3යි ඇර. එතකොට ඔයාලට ඕනනම් තව වේස් තියෙනවා ලියන්න. එහෙනම් නෙගටිව් ඉන්ෆිනිටි ටු 1 වෙනකන් ගෙනහල්ලා 1 ඒත් අයිති නැහැ. ඊට පස්සේ ඕනනම් මෙතනිනුත් ඔයාලට නැත්නම් 1 to 3 ගෙනහිල්ලා ආපහු 3 වලට වඩා විශාල x කියන ඔය ඩිෆයින් ටික කරන්න පුළුවන්, ප්‍රශ්නයක් නැහැ. ඒත් එකම අන්ඩර්ස්ටෑන්ඩ් එක තමයි තියෙන්නේ. මේක එකට වඩා කුඩායි x ඔය විදිහට ලියන්නත් පුළුවන් රේන්ජ් තුනකට. එහෙම නැත්නම් මේ විදිහට ලියන්නත් පුළුවන්. නැත්නම් x belongs to R කියලා දාලා but x unequal 1 and x unequal 3 කියලා ලියලා ප්‍රශ්නයක් නැහැ. ඔය කියන ඒ එක මොන විදිහකට හරි අපිට මේකේ ඩොමේන් එක එක්ස්ප්‍රස් පෙන්න ගන්න ලියන්න පුළුවන්. right? හැබැයි අර විදිහට විතරක් ලිව්වොත් x එකට වඩා කුඩා සහ එක තුනට වඩා විශාල කියලා ලිව්වොත් අපි පොඩි يعني පරාසයක් අතාරිනවා ඩොමේන් එකේ. right? ඒකත් එහෙනම් ඒකට ඉන්ක්ලූඩ් කරගන්නවා. right? මෙහෙම ලියලා අර ඉන්ටර්මීඩියට් ලෙවල් එකත් ඔයා විස්තර කරන්න වෙනවා. එතකොට මෙතන ඉඳන් එකට වඩා විශාලයි x කියා කුඩායි 3 කියන අවස්ථා ටිකක් ගන්න වෙනවා. right?
Okay, sir.
okay. හරි. දැන් අපි එක එක විදිහේ කතා කළානේ. අපි බලමු තව අවස්ථාවක් ඩිෆරන්ට් එකක් hx equal tan x. දැන් අපි වෙනත් තැනකට එනවා. trigonometric function sorry. hx equal tan x. So tan x we can write sin x over cos x, right? So here now you have the way. What is the situation that we have to handle every time cos x should not equal to 0 is the situation that we have to handle. We have to take care about that, right? So now we have to write the domain. Now you can find where the x values what cos x make 0. cos x කියන එක නැත්නම් මේ පදය බිඳුව වෙන අවස්ථාව දැන් ඔයාලට හොයාගන්න පුළුවන්. මොකද අපේ සෙටිස් අවස්ථාව තමයි අපි ලියන්න ඕන එක තමයි ඩොමේන් එක ලියනකොට කොයිම වෙලාවත් මේ යට මේ ඩිනොමිනේටර් එක බිඳුව වෙන දෙන්න බෑ. ඒ කියන්නේ මේකේ ඩිනොමිනේටර් විදිහට ඉන්නේ cos x. cos x එක හැම වෙලේම බිඳුවට සමාන වෙන්න ඕනේ. So now you can find the domain where the cos x is equal to 0. Then you can write the domain without that number. So cos මොනවාරි angle එකක් බිඳුව වෙන්නේ මොන අවස්ථාවලද? ඔයා cos කියන ෆන්ක්ෂන් එක වෙන දැනගන්න ඕනේ. මොන වගේ θ values වලටද cos බිඳුව දෙන්නේ. මුලින්ම මම එකක් ලියන්නම්. cos බිඳුව ඔයගොල්ලෝ දන්නා එකයි. එහෙනම් cos 90 තමයි බිඳුව දෙන්නේ. ඊට පස්සේ ඔයගොල්ලන්ට ආපහු rotation එකක් යනකොට කාටිසියන් එකේ ආපහු 90 ඊළඟට මොකක්ද දෙන්නේ? මොකක්ද?
270.
ආපහු බිඳුව දෙනවා. ඉතින් මේ සිටුේෂන් ටික වලට දෙනවා ආපහු ඊළඟ සයිකල් එක යනකොට ආපහු එකක් එනවා. ඒ කියන්නේ මේ ඔක්කොම අපි අත්හැරලා තමයි මේක ගන්න වෙන්නේ. We have to consider those. So we are not going to write the angles as like this. So we can write this as in the radians. 90 degree means 5/2. So we can write this the domain we can put each and every value but without this 5/2. Then 270 means 3/2. Sorry, not 3 2 3/2. Then again 5/2. These things, right? We have to consider. We can write this like this way: x not equal to 5/2, 3/2, 5/2, like that. So we have to neglect or remove these situations which make the cos x equal 0. Then we can write the domain. So that is the way of handling or finding the domains of the different functions. So the situations that we have to think, whether it contains square root or whether it contains denominators, and the other thing is realistic problem. When you go these three areas, then you can give the correct answers for the finding out the domain of the function, right? Okay, let's take another example. Little bit harder one. Function is x squared minus 5x plus 6. So this is the function. So you can verify this. Yes, this is a function because this contains only positive square roots, right? This is a function, right? The problem is write down the domain. Okay, how to handle this? So this contains square root. So what is the thing that come to our mind when it has a square root? අපිට මේ square root එකක් දැක්ක ගාම අපිට මනසට එන දේ මොකද්ද? square root එක ඇතුලේ තියෙන මේ content එක හැම වෙලේම මොකද්ද වෙන්න ඕනේ? greater than or equal 0 වෙන්න ඕනේ. Because we cannot handle the negative values of the square root, right? They are undefined. So always we need to maintain the things inside the square root into positive. So this is the requirement, right? Okay, now this the we can simplify this equation. Minus 5 means x minus 3 x minus 2. So you can simplify this. Now we can come to the situation. So these are the critical points: x equal 3 and x equal 2. Right? So when x equal 3, this one give 0, and x equal 2, this one give 0, right? So let's draw some line, integer line, and mark the numbers. So number should be 2 here. Then the critical point is 3 here, right? So this our function inside the square root. So let's take, or let's put some number, something less than 2. So you can take any number in this end. So I will take 1. Let's take 1. Right? Let's put 1 into this formula. Number දෙකට වඩා මම කුඩා ගයක් දානවා මුලින්ම formula එකට. මොකද වෙන්නේ කියලා බලන්න. මට ඕන දැනගන්න මේකේ output එක positive ද negative ද කියලා. දෙකට වඩා කුඩා ගයක් දැම්මා. I need to know whether the value or output of the formula is negative or positive when we insert the number less than 2, right? So I will check it by inserting 1. When I insert 1 to the here, so first portion, it will give negative value because 1 minus 3 means minus 2, and 1 minus 2 means minus 1. Again, it is a minus value. So minus multiplied by minus means positive. So when we insert the numbers less than 2, it will generate positive. Right. Then I will take this portion. The number greater than 3. So I will take number 4. Okay. Now I'm going to insert number 4 to this formula, right? Number 4. 4 minus 3. 4 minus 3 means 1. So it is positive. Then again, 4 minus 2. Again, it is positive, right? Positive times positive means will take or generate positive value. So formula generate positive outputs. Okay. Now, 2 areas we are cleared. We have cleared, right? So now we have to look at this area, right? Let's take the number belongs to this range. Let's take 2.5 because 2.5 is lies in between 2 and 3, right? Okay, let's apply the insert the 2.5 into this formula. 2.5 minus 3. 2.5 minus 3. Is it positive or negative? 2.5 negative. Then 2.5 minus 2.
Positive.
Positive. Then negative multiply by positive. It is
Negative.
negative. Right. Now we clear all the areas. Now we know how this function, inside this function, give us the outputs when we insert the real numbers into it. Because this is our main function. Because inside this main function, we take out this formula and check whether it gives us a negative values, because this has a square root here. So we have to care about the square roots, because if we apply some value into domain which make the negative values inside the square root, then we broke our rules, because the function cannot be actually we cannot handle the undefined situation, right? That's the case, right? Now we know that in between these two numbers, number 2 and number 3, this formula generates negative result, negative outputs. So we have to consider the domain without having the numbers in between 2 and 3. Then it is okay, right? So when we define the domain, we can write like this. Domain should be from negative infinity to what? Number 2. So 2 is there. We can apply the number 2 here, no matter, it is equal to 0. So square root of 0, it is not undefined, right? Okay, then after that, right, we can write union here, right? Starting from 3 row, number 3 to positive infinity, right? So this is the domain. In between number 2 and 3, we cannot put into the domain because it will generate negative inside the square root. So this is the domain. If someone asks and give you a function like this and ask the domain, the answer is this. So now you have an idea about the domain, how to find the domain, right?
Excuse me, sir.
Yes.
Are there any other methods to write the domain of the function?
Anyhow, you need to combine these two area, right? So you are seen like that way. I think you can write this one. 2 is less than or equal to x, and 3 greater than or equal 3, and you asking, can I join like this way, representing the domain. Actually, if we use the union, right, in formal way, then we are writing the numbers as like this way, and we are not using the terms in greater than or equal like that with the union. So it is better to write the answers in this way, but for your understand, it is not matter, but representing the answer for some question, it is better answers in this formal way, right? Okay. So sometimes you may met this kind of situation. Fx equal x squared minus 2. No, not minus 2. Let's take minus 4. And denominators, we have x minus 2. Right? So this is the function. Right? So now you have a procedure. What is the procedure? This contain denominator. So always you have to keep that denominator not equal to 0. So you can take out x minus 2 equals 0, and you can find the critical point. So you can write the domain. The domain is the real numbers, but excepting number 2, right? Okay. But you can see here something here, because this is x squared minus 4, no? So you can simplify this and see x squared minus 4, someone can write here 2 squared, right? These are the O levels. No? Now you can write x squared minus 2 squared, x minus 2, x plus 2. Here we have x minus 2. Now you can cancel out this because these are similar. So then we have fx equal x plus 2. Now we modify our basic function, right? And we come to this point. Now function is fx equal x plus 2. Now what happened to domain? Domain is a real number, right? No any serious cases inside here. So what happened? Now what is the correct one? Is this one or this one? So what is the correct one? Actually, we cannot do that. We cannot cancel out the domain, right? Original domain. We have to keep the original domain, right? That means you cannot cancel out the domain problems. Here we have a domain problems because we have denominators here, but we can remove the denominators by simplifying this. So that means we are cancel out the domain problem. Now, at that situation, we don't have any domain problem. The thing is, we cannot do it, right? The thing is, we have to consider the domain problem, and this is the correct answer for this. So we cannot cancel out the domain problem, right? So you have to keep it in mind. In some cases, some problems, some situations, if your functions behave as like this, so you can simplify it and you can cancel out the domain issues, domain problems. But you can simplify it, but you have to keep the original domain, right? That means you have to write this, right, without x equal to for this case, right? In some cases, you cannot simplify. For example, you have x squared plus 3 and the denominator is x minus 2. Right? So it's very similar, right? Very similar functions, but you can see different. In here, you can cancel out the domain issues. And here, you cannot simplify this. You cannot cancel out the problems, domain issues. So there are two types of categories in this problems, right? So you may make these two. In first case, you may make this kind of situations. You can cancel out the domain problems, and sometimes you may make these kind of things. So in this case, you don't have any issues. Only you have to consider the things, problems having the denominators. In here, what is the case? You can simplify, but you have to consider the domain problem which has the initial state. So these are the things you have to keep in mind, right? So now I write here some examples and show how to write the domain, right? So you can do some examples at home. I will try to upload some formulas to train to find out the domain, right? So please stay with the LMS, right? LMS on that day. So I will upload the document. So please try to find the or solve the problems available on the LMS. I will upload by today or tomorrow, right? So the time now come to the 12 plus, already 12 plus, right? So and now I'm going to close the today's session. So I think now you have some idea about the actually functions. So we have a large area to learn inside the calculus. So first part I started today, it is about the functions. Now you may have some idea about the function. What are the rules inside the function? Actually, what is the function? The domains of the function, right? As well as the range. Range is still we didn't do anything about the range. So I will come with later, but it is very easy. But we have the problem defining the domain, right? So we have to clear those areas. Now we can understand how to write the domains also. So range is not too much, right? Because when we know the domains, we can find out the range, no matter, right? So these are the things what I covered today, right? So I will try to upload the recordings also. Then if you have some missing parts, so you can go through the recordings also. So let's meet again on next Wednesday, no? Yes, Wednesday. So time may little, I don't know whether it changed because to morning lecture, I don't, sometimes it may shifted to the another time slot. So if the time is changed, I will notice it on the LMS. Otherwise, please join to the link on next Wednesday at 10 p.m. Sorry, 10 a.m. Sorry, not p.m. a.m. Right? Okay. Thank you very much for joining today. So now I will close the session. So before to close the session, do you have any clarification to මොන හරි තියෙනවා නම් දෙයක් අහන්න මේ වෙලාවේ එහෙම නැත්නම් නෝට් ඩවුන් කරගෙන ඊළඟ දවසේ අහුවත් ප්‍රශ්නයක් නැහැ. සිංහලෙන් කතා කරත් ප්‍රශ්නයක් නැහැ. හරිද? මොන හරි ප්‍රශ්න තියෙනවා නම් අහන්න. මම සිංහලෙන් කතා කරන්න උත්සාහ කරනවා. ඒ කියන්නේ දැනුම මේ අපිට වැදගත්ම දේ. ඒතර ඕගොල්ලන්ට මොන හරි ඉෂුස් තියෙනවා නම් කතා කරන්න. සිංහලෙන් ප්‍රශ්නයක් අහුවා කියලා ප්‍රශ්නයක් වෙන්නේ නැහැ. හරි?
Excuse me, sir.
ඔව්.
සර් රේන්ජ් එක ලියනකොට ඉන්ෆිනිටි එකේ මේ ස්ක්වයර් බ්‍රැකට් එකයි රවුන්ඩ් බ්‍රැකට් එකයි යූස් කරේ පොඩ්ඩක් ඒක හේතුව පොඩ්ඩක් පැහැදිලි කරන්න.
right. රේන්ජ් එකේ නෙමෙයි රේන්ජ් එක කියන්නේ අතන ඩොමේන් එක ලියනකොට අපේ රේන්ජ් කිව්වම මේ ළඟද වෙන අයිඩෙන්ටිටි එකක් තියෙන්නේ ෆන්ක්ෂන් එක රේන්ජ් එක. ඒතර අපිට මෙන්න මේක නේ ප්‍රශ්නේ. ඒතර මේ වගේ දෙයක් ලියනකොට මේ ස්ක්වයර් බ්‍රැකට් එක දාන්නේ මේ කියන සංඛ්‍යාව included කියන එක. right? අපි ලිව්වොත් මම මේ ඉන්ෆිනිටි මුලින්ම ගන්න නැතුව මෙහෙම දාන්නම්කෝ 1 to 7 දෙපැත්තම ස්ක්වයර් බ්‍රැකට් දැම්මොත් මේකේ තේරුම both numbers are included in between 7 and 1. This is the meaning. Right? So if you write in this way, that meaning of this is number 1 is not included to the domain, right, or range, right? That means we cannot put here equal sign, but 7 is there. Okay, now you are asking why we put this bracket without putting the square bracket, right? So we actually infinity is actually we cannot put the exact number, right? So negative infinity or plus infinity අපිට මේ අනන්තය කියන දේ අපිට හරියටම define කරන්න පුළුවන් exact point එකක් නෙවෙයි. එතකොට මේකේ අපි include කරනවා නම් ඒක exact point එකක් වෙන්න ඕනේ, right? එතකොට එයා ඒක නිසා තමයි එයා exact point එකක් නොවන නිසා තමයි, right? මේ විදිහට අපි මේ bracket එක use කරන්නේ infinity එක define කරනකොට හැම වෙලේම අනන්තයත් එක්ක අපි කවදාවත් square bracket එකක් දාන්න එපා. You cannot use the square bracket with the infinity, any negative or positive infinity, right? Right? It is wrong, right? So with the infinity, you have to use this bracket. So that is the difference of the using of this bracket. Now I think you can understand it, right? තේරුණාද මේ අවස්ථාව?
Yes, sir. Thank you.
Hari, okay. Thank you very much. Then I will close the session and I will do the things what I explained. That means uploading the materials and the recording within today or tomorrow, right? Okay. And please stay with the LMS. If I upload some questions, then you have to do, right? But I will not, I didn't prepare yet, right? But I will do, right? Okay. Then thank you very much.
Thank you, sir.
Thank you, sir.